All right, so in this video, what I'm going to do is I'm going to compare these four methods that we've talked about for determining the volume of some three-dimensional solid. So I'm going to start off by mentioning a few important facts that everyone hopefully will know by the end of this video. First and foremost, these first three methods, cross-sections, discs, and washers, all have something in common, and it's all that they have another name called slicing method. Okay, these are all slicing methods. The reason they are called slicing methods is what they are doing is they are taking a three-dimensional solid, something that's actually physically tangible in three dimensions, and what they're doing is they're cutting it, so all we're looking at is a two-dimensional section of it. Okay, so again, with cross sections, we're looking at what that shape actually is. For discs, we're looking at one solid circle. For washers, it's a circle with a hole in it. However, the shell method is not a slicing method because it is not taking a three-dimensional solid and slicing it into a two-dimensional shape. It is taking a three-dimensional solid and keeping it as three dimensions, just making it stacked inside of each other. Okay, so that's an important fact right off the bat, is these three methods are all slicing methods. The shell method is separate. Now, another thing that you should be able to notice at this point is with cross sections. We are talking about simple geometric shapes for the cross section. Now, usually we're actually given the word cross section. It says something about what it looks like, okay? Whether it's a circle, a square, an equilateral triangle, a rectangle, whatever shape it is, it's usually going to use the word cross section. One of the other things we need to look out for is when it says what it's perpendicular to, okay? Now, that perpendicular part comes in handy, and I'm going to talk more about that in a second. So the perpendicular part, remember the symbol is the upside down capital letter T. If we're talking about perpendicular to the x-axis, I write it in terms of x. If we are perpendicular to the y-axis, we are using it in terms of y values, okay? Now, again, these are important things. One of the other things you need to remember, again, is we're talking about it in terms of the area formulas of those figures. So here's the thing. The cross-section method is very, very similar to Riemann sums because when we did Riemann sums, we were slicing a two-dimensional figure into little bitty geometric shapes that were easy to calculate, rectangles. In this case, when we do cross-sections, we're taking a three-dimensional figure, not a two-dimensional figure, a three-dimensional figure, and slicing it into simple geometric shapes like rectangles, squares, equilateral triangles, any of those things we can calculate the area of easily, okay? So let me repeat again. The cross-sections method and Riemann sums are very, very similar. They have to do with taking a shape and slicing it into simple geometric figures. Now, discs are not going to necessarily tell you which, it's not going to have something that says use the disc method all the time. Neither is washers or shells. We're more likely to see something that says use the shell method for the shell method. But there are a lot of problems that just say use one of them. Now, again, cross-sections use a special kind of solid, one that we actually know the cross-section of. The disc washer and shell method all have something else in common. These all three of these, deal with solids of revolution, where we have one region that gets rotated around an axis or a line, okay? So all of that stuff is really, really important. Now, that I've mentioned all of that information, again, the first three have something in common, they're slicing methods. The last three have something in common, they're dealing with solids of revolution. So all three of these things are going to have some axis, some line of rotation. Now that I've mentioned that, I'm going to go ahead and talk about a few other things. Number one, some of these methods are pretty interchangeable, okay? So one of the things I wanted to point out to you, like for instance, this one, what we're going to do is we're going to calculate the definite integral of pi r squared, okay? What we're going to do is we're going to write the radius in terms of either x or y. And the reason we do that is because it's perpendicular to my axis or line of revolution. Okay, so let me repeat again. If we are using if we're using an axis of rotation of x-axis, we're going to use x values. If we're using an axis of rotation of y-axis, we're going to use y values here. if I'm doing washers, it's going to look very similar. Remember, it's still pi times r squared, but the problem is we have two r's this time. We have a bigger r, an outer radius, and an inner radius, a little r, okay? Again, this is still using the concept of perpendicular. Again, let me repeat one more time. If it's x-axis of rotation, then it's x values. If this is a y-axis of rotation, it's y values. The one that's special here, shells, it's not actually going to be the same way. It's no longer perpendicular. We're actually going to use a parallel axis of rotation. So here's the thing. If we have an x-axis as our rotation, we're going to use y values. If we have a y-axis of rotation, then we're going to use x values, okay? Hopefully you guys picked up on that from the first and second examples, that when we were rotating around the y-axis, we left it in terms of x values. Here's the thing. If we're using the x-axis as the rotation, switch it to y's. All three of these were the same as their axes. If it's these for shells, make sure you switch the variables. X-axis goes with y's, y-axis goes with x. That's a big common mistake I see with a lot of kids. Again, this formula is a little bit different. So we're going to do from A to B of 2 pi times the radius times the height. And that height is the function, and the radius is usually just x or y. There are some cases where when it's not the x-axis or the y-axis, it might be x plus 1 or x plus 2 or x minus 1. It just might be a little bit slightly different depending on where the axis of rotation is, okay? So, wanted to make sure I pointed out these things to you. Again, these three are all similar. These three are all similar. They all have things that make them in common that kind of make things a little bit nicer. And I just wanted to make sure you guys saw how related all four of these things are, while at the same time they're all slightly different, okay? Hopefully this helps you guys understand these different methods a little bit better. Again, big thing here is with the shell method. If you're revolving around the x-axis, make sure you use y values. If you're revolving around the y-axis, you're going to use x variables. For these, they're all the same, okay? This is the special case, but this one works when these others won't, okay? So hopefully that does, again, help you. If you have any questions, please feel free to ask me.